Picture this. It's 1975, and you're standing in a small garage in Sao Paulo, Brazil. The air is thick with humidity and the sweet smell of sugarcane alcohol. A mechanic named Paulo Gomes is about to do something that Volkswagen's best engineer said was impossible. He's going to make a Beetle engine run on pure ethanol, and not just run, but run better than it ever did on gasoline. What Gomes discovered in that garage would eventually force one of the world's largest automakers to completely reverse their engineering philosophy. It would transform Brazil into the global leader in alternative fuels. And it all started with a mechanic who refused to believe the experts. This is the story of how one Brazilian mechanic outsmarted Volkswagen with a secret Beetle engine modification that ran on sugarcane alcohol and changed the future of fuel forever. To understand why Paulo Gomes' achievement was so revolutionary, we need to travel back to Brazil in the early 1970s. The country was in the grip of an energy crisis that made America's gas lines look like a minor inconvenience. When OPEC quadrupled oil prices in 1973, Brazil found itself spending over half its export earnings just on petroleum imports. The situation was desperate. Brazil had no domestic oil production to speak of, but it had something else in abundance: sugarcane. Millions of acres of it. The Brazilian government launched an audacious plan called Pro-Álcool, the National Alcohol Program. The idea was simple but radical. Convert the nation's vast sugarcane crops into fuel alcohol, known as ethanol, and use it to power vehicles. There was just one problem. Nobody knew how to make it work reliably. Volkswagen dominated Brazil's automotive market in the 1970s. The Beetle, or Fusca, as Brazilians called it, was everywhere. VW had manufacturing plants in Sao Paulo that churned out thousands of air-cooled Beetles every month. These cars were engineered with typical German precision for one fuel and one fuel only: gasoline. When government officials approached Volkswagen about converting their engines to run on ethanol, the response was swift and dismissive. VW's engineers presented a laundry list of technical impossibilities. Ethanol, they explained, has fundamentally different chemical properties than gasoline. It contains oxygen atoms that gasoline doesn't have, which changes the stoichiometric ratio, the ideal mixture of fuel to air for combustion. Gasoline needs about 14.7 parts air to 1 part fuel. Ethanol needs only 9 parts air to 1 part fuel. That's a massive difference that would require completely redesigning the fuel system. But the problems didn't stop there. Ethanol, the VW engineers warned, is hygroscopic. It absorbs water from the air. This would lead to corrosion throughout the fuel system. Fuel tanks would rust. Fuel lines would deteriorate. Carburetors would corrode from the inside out. Even if you could solve those problems, ethanol has less energy density than gasoline. A gallon of ethanol contains about 30% less energy than a gallon of gasoline. The engines would be gutless, they said. Performance would be unacceptable. VW's position was clear. Converting their precisely engineered gasoline engines to run on ethanol was technically unfeasible and economically irrational. They had decades of engineering expertise and some of the best automotive engineers in the world. Who was going to argue with that? Enter Paulo Gomes. Gomes wasn't a university-trained engineer. He didn't have access to VW's research facilities or million-dollar testing equipment. What he had was a small garage in Sao Paulo, decades of experience working on Beetle engines, and something the VW engineers apparently lacked: an open mind about what was possible. Gomes had been repairing and modifying Beetles since the 1960s. He knew these air-cooled engines inside and out. Every quirk, every weakness, every hidden reserve of potential. When customers started asking him about ethanol conversions in 1974, driven by fuel shortages and government incentives, Gomes decided to figure it out himself. The first challenge was the carburetor. The Beetle's Solex carburetor was calibrated precisely for gasoline's stoichiometric ratio, Simply pouring ethanol into a gasoline-tuned engine would create a dangerously lean mixture, too much air, not enough fuel. The engine would run hot, knock, and eventually destroy itself. Gomes started by completely disassembling a Solex 30 Pix-T carburetor. He measured every jet, every passage, every orifice. Then he did the math. If ethanol needed a 9:1 air-fuel ratio instead of gasoline's 14.7:1, the fuel jets would need to flow approximately 40% more fuel. But you couldn't just drill out the jets randomly. The progression had to be perfect across the entire RPM range, from idle to full throttle. Using precision drill bits and careful measurements, Gomes enlarged the main jet from 127.5 to 185. The idle jet went from 50 to 65. The accelerator pump jet increased from 50 to 60. But here's where Gomes's practical experience trumped theory. He discovered that ethanol's higher latent heat of vaporization meant it cooled the incoming air charge more than gasoline. This cooling effect increased the density of the air entering the cylinder, which meant the jetting didn't need to be quite as rich as pure mathematics suggested. The next modification was even more radical. Gomes increased the compression ratio. The stock Beetle engine ran about 7.5.1 compression, relatively low even by 1970 standards. This was partly for durability, and partly because Brazil's gasoline was terrible quality, often below 80 octane. But ethanol has an octane rating of about 113. It can withstand much higher compression without detonating. Gomes had the cylinder heads milled, removing 2 millimeters of material from the combustion chamber surface. He calculated this would increase the compression ratio to approximately 12.1. That's race engine territory. The VW engineers would have been horrified. High compression means more stress on every component: pistons, rods, crankshaft, bearings. Everything has to work harder. But Gomes understood something the VW engineers had missed. Ethanol's cooling effect and slower flame propagation actually reduced peak cylinder pressures despite the higher compression. The engine wasn't working harder, it was working differently. The ignition timing needed adjustment too. Ethanol burned slower than gasoline, so the spark needed to come earlier to give the flame front time to develop. Gomes advanced the timing from 7.5 degrees to 12 degrees before top dead center at idle, with total advance reaching 32 degrees at high RPM. Now came the corrosion issue. VW was right that ethanol could attack certain materials, particularly rubber and some metals. But Gomes found simple solutions. He replaced rubber fuel lines with alcohol-resistant synthetic lines, a modification that cost less than $20. He coated the inside of the fuel tank with an epoxy resin that was impervious to ethanol. The carburetor's zinc components were replaced with brass equivalents. By early 1975, Gomes had his first fully converted ethanol Beetle running. And that's when things got interesting. The car didn't just run, it ran beautifully. The engine started easier in cold weather because ethanol vaporizes at a lower temperature than gasoline. The idle was smooth, throttle response was crisp. But the real surprise came when Gomes put the car on his homemade dynamometer. The stock 1300cc Beetle engine produced about 46 horsepower on gasoline. Gomes's ethanol-converted engine was putting out 55 horsepower. That's a 20% increase. The VW engineers had said ethanol would reduce power. They were completely wrong. How was this possible? It came down to several factors the VW engineers hadn't considered. First, the higher compression ratio extracted more energy from each combustion event. Second, ethanol's higher octane allowed more aggressive timing without detonation. Third, and most importantly, ethanol's cooling effect meant you could run richer mixtures without the usual penalty. In a gasoline engine, running rich wastes fuel and reduces power. But with ethanol, the extra fuel actually cooled the combustion chamber, allowing even more timing advance and higher effective compression. Torque increased too, from 77 Newton meters to 91. The engine pulled harder at low RPM, making the car more pleasant to drive in city traffic. Fuel consumption did increase, about 30% more ethanol than gasoline by volume, but ethanol cost less than half what gasoline did in Brazil. Drivers would save money even while using more fuel. Word of Gomes' miracle ethanol conversion spread through São Paulo like wildfire. By mid-1975, he had a 3-month waiting list. Other mechanics tried to copy his work, but most failed to get the calibration right. Too rich, and the engine ran poorly. Too lean, and pistons melted. Gomes had found the sweet spot through hundreds of hours of testing and refinement. The conversions became known as Gomes spec engines. Taxi drivers loved them because the fuel savings meant more profit. Performance enthusiasts discovered that ethanol engines could be pushed even harder. Some builders were getting 70 horsepower from naturally aspirated 1300cc engines using ethanol and aggressive cam profiles. But Gomes's most important convert wasn't a customer. It was a VW engineer named Hans Müller who brought his personal Beetle to Gomes's shop in late 1975. Müller was skeptical but curious. He watched Gomes work, asked detailed questions, and drove the converted car extensively. Then he did something unexpected. He convinced VW Brazil's management to bring Gomes in as a consultant. The meeting at VW's São Paulo headquarters was tense. Here was a self-taught mechanic telling PhD engineers they'd been wrong about everything. But Gomes had something they didn't, working cars that proved his point. VW's testing confirmed what Gomes had discovered. Not only did ethanol engines make more power, they actually lasted longer. The cooler combustion temperatures reduced thermal stress. The absence of carbon buildup from gasoline's aromatic compounds kept valves and combustion chambers cleaner. Oil stayed cleaner longer because ethanol doesn't create soot. VW's engineers had made a classic mistake. They'd analyzed ethanol's properties in isolation, without considering how those properties would interact in a real engine. They saw lower energy density and assumed less power. They saw alcohol and assumed corrosion. They saw different stoichiometry and assumed impossibility. They were thinking like chemists, not like mechanics. Gomes had approached the problem differently. He started with what worked and modified from there. Each change revealed new possibilities. Higher compression worked because of ethanol's octane. Richer mixtures worked because of cooling. Advanced timing worked because of slower flame speed. Everything interconnected in ways that pure theory couldn't predict. By 1976, VW Brazil was secretly developing their own factory ethanol Beetle using Gomes principles. They made some refinements, better materials for long-term durability, more precise fuel metering, improved cold start systems. But the core concept was pure Gomes: high compression, rich mixture, advanced timing. The first factory ethanol Beetles rolled off the production line in 1978. They were an immediate success. By 1980, over 90% of new cars sold in Brazil could run on ethanol. The Pro-Alcool program that seemed impossible in 1973 had become reality, largely thanks to one mechanic who refused to accept impossible. The technical implications of Gomes' work extended far beyond Brazil. He had demonstrated that internal combustion engines were far more adaptable than anyone realized. Fuel flexibility wasn't just possible, it could actually improve performance. This insight would eventually lead to flex fuel technology that could automatically adjust to any mixture of gasoline and ethanol. Modern direct injection engines use principles Gomes discovered in his garage. They vary compression ratios dynamically. They adjust injection timing and quantity in real time. They use ethanol's cooling effect for knock suppression. The 2020 Koenigsegg Gemera hypercar makes 600 horsepower from a 2.0-liter three-cylinder engine running on ethanol, a specific output that would have been unimaginable without understanding ethanol's unique properties. Brazil's ethanol industry now produces over 30 billion liters annually. The country hasn't imported oil for transportation fuel since 2006. Sugarcane ethanol reduces greenhouse gas emissions by 90% compared to gasoline. An entire nation's energy independence started in Paulo Gomes's garage. But perhaps the most important lesson from Gomes's story isn't technical, it's philosophical. The VW engineers weren't stupid. They were brilliant, highly trained professionals with vast resources, but they were also constrained by assumptions. They knew what couldn't be done because theory told them so. Gomes didn't know what couldn't be done, so he did it anyway. This pattern repeats throughout engineering history. The Wright brothers were bicycle mechanics who solved powered flight, while better-funded experts insisted it was impossible. SpaceX lands rockets on boats, while NASA said reusability was impractical. A Brazilian mechanic makes Beetles run better on sugarcane, while Volkswagen's engineers explained why it wouldn't work. Gomes retired in the 1990s, his garage now a small museum. But his legacy lives on in every flex-fuel vehicle, every E85 performance tune, every race car running on alcohol. He proved that expertise without experimentation is just expensive ignorance. That sometimes the best engineering happens not in laboratories, but in garages, where someone is willing to try what everyone knows won't work. The next time someone tells you something is technically impossible, remember Paulo Gomes. Remember that Volkswagen, one of the world's premier engineering companies, was completely wrong about what their own engines could do. Remember that one mechanic with dirty hands and an open mind revolutionized an entire nation's energy system. Engineering isn't just about knowing how things work. It's about discovering how they could work if we're brave enough to try. Gomes wasn't trying to revolutionize transportation or save Brazil's economy. He was just trying to help his customers save money on fuel. But by refusing to accept conventional limitations, he ended up doing both. The ethanol Beetle became an icon in Brazil, outselling gasoline versions by 1983. VW eventually developed dedicated ethanol engines with even higher compression ratios and sophisticated engine management systems. But they never forgot the lesson from Gomes's garage. Sometimes the best innovations come from people who don't know what's impossible. Today, Brazil's flex-fuel vehicles can run on any mixture from pure gasoline to pure ethanol. The engine management system automatically adjusts compression, timing, and fuel delivery in real time. It's sophisticated technology that seems almost magical. But at its core, it's doing exactly what Paulo Gomes did with hand tools and determination, making an engine run on whatever fuel is available. The story of Paulo Gomes and his ethanol Beetle is more than just automotive history. It's a reminder that innovation doesn't always come from the top down. Sometimes it bubbles up from small garages where curious minds refuse to accept "that's impossible" as an answer. So the next time you see a flex fuel badge on a vehicle, remember the mechanic who started it all. Remember that Volkswagen's best engineers were wrong and a self-taught mechanic was right. Remember that the future of transportation was shaped not in a German laboratory, but in a Brazilian garage that smelled of sugarcane and possibility. What seemingly impossible problem could you solve if you stop believing the experts who say it can't be done? Drop a comment below with your thoughts on alternative fuels and engineering innovation. And if you enjoyed this deep dive into automotive history, make sure to subscribe for more stories of unlikely innovators who change the world from their garages. Until next time, keep questioning what's possible.